Well, hi everyone and welcome back. In this video we'll be covering the topic of faults, which is very important to geology, and I want to cover several things today. First, what a fault is, the basic definition, how and why faulting occurs, and then several different types of faults that we have in the world, some of the most basic ones. But with that, let's get started. So the definition of a fault is simply a break or rupture in a body of rock, right? A break or a rupture. And this generally occurs due to brittle failure. And if you've been in material science or you're familiar with it, then you'll recognize brittle deformation is a kind that occurs under high pressure, low temperature, and it results in a excuse me, a break in the rock, or any surface really, that cannot be undone. It's not like an elastic or plastic. Until a certain threshold is reached, it can go back to where it was. Simply put, the change is permanent. And these faults are usually marked by discontinuities in the bodies of rock. And that simply means that, well, since rock is being deformed and you'll have some movement in there, some displacement, that you're not going to see just straight, nice, orderly strata overlying each other. You're going to see parts where certain areas of certain strata will be shifted upwards or downwards or left and right, and it'll look much less clean than we would be used to. So that's what a fault is in its most basic terms. But then there's the question of why faulting occurs, and this question is answered mostly by plate tectonics. Now, faulting can occur within plates themselves, but most of the time it has to do with plate tectonics. And you'll see fault zones at plate boundaries, such as the famous San Andreas fault. But this occurs because, as you hopefully are aware, the Earth is constantly in motion, and you'll have plates moving over, moving under, scraping past each other. But this doesn't happen in a very lubricated fashion. It's more like they're grinding against each other, and as pressure builds up, eventually it's released in a giant burst. This type of motion is described as stick-slip. And there's a good analogy for it, I think. If you have a door, right, a jammed door, and you try to force it open, you're going to have to apply a lot of pressure before it finally gives way. Now, you may have unjammed the door and now it's open, but when you close it again, well, it gets jammed. So, effectively, when the pressure is released, you just reset. Faults are constantly in motion. Once a fault's pressure is released, it goes back to a state of just grinding again. So we get this, over time, faults will deform more and more, and you'll see several periods of small bursts that they'll experience. Another way of looking at it is in a simpler way. Just if you've got, say, a plastic ruler and you bend it, and at first there's very little deformation. That's like when the plates are just scraping past each other a little bit. But then when enough pressure builds up, it snaps, and that's the brittle deformation that we know as the fault. So with the definition and why faulting occurs out of the way, then we could get into actual types of faults. And we'll start with what are known as dip-slip faults. And what these mean is that there is a vertical motion So if, for example, we've got our, we'll draw a block diagram here. We've got, there's our fault. So, if this is our picture, then originally this looked like this, just a uniform bed, right? It was just, it would have been a rectangular block. But since the deformation has occurred, we get one that slips downward like this. And that is known as a dip-slip fault. There's vertical motion, one slips down relative to the other. Now, within dip-slip faults, we have two basic kinds. There are normal faults, and there are reverse faults. Normal and reverse. Okay, simple enough. And as you can imagine, reverse is just the opposite of normal. So they're pretty easy to remember. These terms were actually devised back in the 19th century, I believe. 19th or 20th. They were terms used by miners in the UK, I think, to describe the faults they saw, because they didn't really deal with Strikeslip, the other kind we'll get into, and they basically just said, oh yeah, that's a normal one. I'm assuming because it was the first kind they saw, or maybe it was a more abundant kind. And then anything that wasn't normal was the opposite of normal and reverse. But that's just a little tangent. So a normal and a reverse fault, to understand these, you have to understand components of a fault. So we'll do another little picture here. If we've got a two-dimensional drawing, right? And let's just say no, we'll just draw the line to show where the fault will be. But for now, it's just a piece of rock that hasn't been disturbed. So two terms you have to understand are footwall and hanging wall. And the deal here is the footwall is going to be this piece, call it the FW for short, and the hanging wall is going to be this piece. Now just looking at it, you can kind of see why. The hanging one appears to be hanging over the footwall at the top. The footwall also, if you want to think about it this way, forms a more foot-like shape. As it goes down, it gets wider. I don't know any feet that get narrower as you go down. You can imagine the ankle being right there. Or if you want to imagine it in terms of angles, the footwall will always have the larger angle at the top, an obtuse one. The hanging wall will have the acute one at the top. Meanwhile, the hanging will be obtuse at the bottom, and the footwall will be acute at the bottom. But when we look at normal and reverse faults, right? I'll start with a normal one. This is a normal fault. There's the footwall. And relative to before, the footwall is higher up. We call that, it's normal when the footwall, relative to how it started, it doesn't matter if this actually moved up or this actually moved down, although a lot of times you'll have some of both. But it doesn't matter which way it goes, just relative to the starting position. The footwall is above where it was. Now because of this, we have a neat little, what do you call them? Whatever. Ways to remember, of remembering this. The footwall, when it is upthrown, thrown upwards, the fault is normal. Or if you take the first three letters of these three words, you get fun. Oh, that's fun. Geology's fun. So footwall upthrown normal. Okay, remember that. And then we'll get into our reverse fault, which is the opposite. You'll see that if here's our footwall, it is below where it initially was. And you'll see something like this. So the hanging wall has been pushed up and the footwall has been pushed down. One or the other or both, whatever it is, it's all relative, right? So our footwall is here, it's gone down. Our hanging wall is here, it's gone up relatively. And with this we can say footwall down thrown reverse. Or if you take the first three letters again, you'll get FDR. Which, if you're familiar with American history, if you're an American or you're at least familiar with what was going on in the 20th century here, you'll recognize that name, hopefully, Franklin Delano Roosevelt. And so it's a pretty interesting way to remember it. If it were the other way around, it wouldn't work, because you get, well, fur works still. If it were footwall up throw in reverse, you get fur, but then footwall down throw normal, you get FDN, which I'm sure there's something somewhere that can be abbreviated as FDN, but you know, fun and FD are much more recognizable, so remember that. And those are our two types of dip slip faults. But there's an entirely different kind, which you can probably see where this is going. We have strike slip faults, which contain horizontal motion. So basically, instead of having one piece moving up and one moving down, you'll see that one is pushed to the left and one is pushed to the right. So if we've got, here's our fault line, and then we've got some land here and some land here on both sides. Yeah, maybe we've got some happy little trees in there. Maybe a fence. Just drawing stuff at this point. But if you have a strike slip fault, then one is going to be pushed to the left and one is going to be pushed to the right. So in this case, let's say this one here gets pushed to the right, and we see this block now on this side. This tree's been translated over. And so we see it like this. Now, right off the bat, you can say that's a strike slip fault because there's clear horizontal motion. But there are also two ways to define these. They are left lateral and right lateral. And those names are hopefully self-explanatory. But there is a bit of an issue because left and right, well, those are relative. Right from one direction could be left from another point of view. So the way we do this is, imagine yourself standing here, right? That's you. That looks just like you. So you're looking at it from right here, right? From where you're standing, this plate right here is the far one. And what can you say about it? Well, it's been shifted this way to the left. So you would say, naturally, that's a left lateral fault. And it holds true for someone on this side, because we have a way of doing this where if there's another person over here, they're not looking at this one, because although to them this would be their right, you always look at the one farthest from you. The one farthest from you. So in that case, this is this one, which is actually closer to me as I draw this. But for this person, well, their rights and left are reversed. So they say this is moved to the left. So whichever way you look at it, it's a left lateral fault. Okay? Simple enough. So you just look at the one farthest from you, and whichever way that has been moved relative to its starting position, you say that is either right or left. Before we move on to our last basic type of fault, there are two other terms that you will hear. They are dextral and sinistral. Sounds kind of like sinister. And basically those are just other terms for dextral is right lateral, and sinistral is left lateral. Yeah, they're kind of scary words, but their meanings are simple enough. If you see that term anywhere, a dextral fault or a sinistral fault, they're nothing too bad. Which finally brings us to our final type of fault here. And it's a pretty interesting one, but it's, once you understand the previous two, it's not too bad. It is an oblique slip fault. And this one we see a lot more in the real world, because oftentimes faults do have this behavior. It is both horizontal and vertical movement. So you'll have a bit of the strike slip and a bit of the dip slip components in there. So if you just want a visual representation of this, we've got another three-dimensional block diagram, because we kind of need these here. Let's say that's our first block. Right there. And then maybe there's another one right there. Something about that doesn't look right. That's right, it needs a top. That looks better. Three-dimensional drawing on the spot. It's not the easiest thing. But basically you can see here, I hope I drew it okay, but you've got fault movement in this direction, the vertical direction. This one has moved down relative to its starting position, if you imagine them when they were connected together. And this one has therefore moved up relative to its starting position. But you'll also see that this one has moved in this direction as well, and this one has moved in that direction. So it's basically just putting this in three-dimensional space and taking into account both the horizontal and vertical components. So we could say that relative to the start, the foot wall was upthrown, because you see that going up here. And if we imagine a person standing here, somewhere off on a piece of land, well, they're looking this way, and this piece has moved to their left. So we can say that it has components of both a normal and left lateral fault. And that's all there is to oblique slip faults. Well, actually there are actual components that you can study, such as the dip, the thrust, the throw, other components that are more numerical than this, but that's a topic for another day. We don't want to get too mathy in this basic introduction video. And there's one final little piece of information I want to cover. And it's just two terms, real quick. Just two more. Horst and Graben. And I've heard this word pronounced several different ways. It's got Germanic roots, I think. I don't really care. But anyway, these two occur, or these two, you would use them properly when you've got parallel faults, which means you got something like this, where you've got two faults effectively right next to each other, such that these two footwalls share one block as their hanging wall. So you know, this is before the movement has occurred. It could go any way. This one could go down, this one could go up. But let's just say that the footwalls are down thrown, so we'll get this. We've got our two footwalls lower than they started out. This one has then come up and created something stranger at the surface. So specifically when we have a case like this, where it's three blocks, one hanging wall, or it could be one footwall, I suppose, but one block is shared by two faults, you'll get something that looks like this. So the one in the middle was upthrown, and this shared hanging wall. But specifically, in this case, we would call this a horst. It is the block that is upthrown in scenarios like these where you've got two faults. And I just remember that horst sounds kind of like hoist. It is hoisted upwards. And then, naturally, the other two, those are the graben. No real clever way to remember those, I guess. It's really a strange word, but, you know, just remember it's the opposite of horst, and you'll be fine. There's a lot more to talk about with faults, but this has been a basic introduction. I hope it was informative, maybe some good review. Either way, hopefully you enjoyed it. Keep doing geology, and I will see you in the next video.